Miss Irvin. This is me, Bethany Powell, your new student. I'm in your 4th period academic math class, and I will show you a video today about how the cone and the cylinder volume are similar. Over here, I'll show you a real-life demonstration of how a cone and a cylinder are the same. Here I have a cone where I tried my hardest to make the same height as the cylinder and the same circle shape as the cylinder. And I'm going to try and fill up this cone how many ever times is needed. As we see here, I filled it up one time fully, and my cylinder is still not empty. So here I have showed you that we already know that our cylinder has a larger volume than our cone. I'll pour it in here. And now I'll try to fill it up again. Here I have filled it up a second time, and still I only have a lot left in my cylinder. And again, recapping just to make sure, I have tried my hardest to make the height and the circle as close as I could to the cylinder. Let's see how many more times we can do it. Again, I have filled it up for a 3rd time, and I have none left. So, we have proved that 3 cones can fit into 1 cylinder. Now we're moving over to my whiteboard. Now we're moving over to our whiteboard. Here I have a problem set up with the cylinder and the cone have the same radius and the same height as each other. Before we work out this problem, I'm going to show you how the two formulas differ. For the cylinder, the pi r to h is the same as the one in the cone. The pi meaning pi, the r meaning the radius, it's squared, and then the h meaning the 12 as the height. So over in our real-world example, we demonstrated that 3 cones could fit into 1 cylinder, which also means that 1 cone equals 1/3 of a cylinder. So here we will work out the problem using our pictures here. So here we'll plug in our numbers. So we'll keep the 1/3. Actually, you know what? I changed my mind. We're going to change it to a decimal because it's a lot easier for my calculator to stay the same. So 1/3 as a decimal is really 3, repeated. But here, we're going to round it to 3.3. And our radius is 4, and then you have to square it. And our height is going to be 12. We will come back to our cone so that we compare it to our cylinder. So the plug-in numbers are going to be basically the same, except for there's not going to be 0.3333333. So we're going to keep our pi. Oh, I forgot to put. We're going to keep our pi. Because I don't like to translate it here. And we're going to do our radius, the 4 squared, and then our height, 12. So, we're going to work out our cone first, knowing it's going to be a smaller number. So, we're going to go ahead and do the 4 squared. So 4 squared also means 4 times 4, which is 16. So we're going to plug in those, 12, and then the pi and the 0.33. And we're going to take the 0.33 and multiply it by 16. which equals 5.28. And we still have the pi with us and the 12. And now we're going to do the 5.28 times the 12, which is 63.36. And we still have the pi in front of us, which means that we're going to have to times that by pi, which equals times 63.36 equals, and we're going to round it, 199.05. And you know what our label is, so we don't have to label it. So we automatically know that this is going to be smaller than this. So if we did have answer choices here, we would already know what our answer was going to be if they had a larger number than that, if they were comparing the cone and the cylinder. So now we're going to do this problem. So we already know that 4 times 4 is 16.
Cone.
And then we have the 12.
Cylinder.
And then we have the pi. So here first we're going to do 16 times 12, which is 192. And then we still have our pi. So 192 times pi equals, we're gonna round, 603.09. So comparing these two numbers, this is their volume. Circle one. This is their volume. So comparing these two numbers, this one is bigger and this one is smaller. In a normal problem where when it tells you to compare the cone and the cylinder, you usually will subtract the 603.09 minus the 199.05, which I'll do on my calculator real quick so you don't have to watch me working it out. And our answer will be, what is it?
603.09
minus
199.05.
So our full entire answer to this problem will be 404.04. And since we're using volume, centimeters squared. So as we can see here, we have proven a couple things with this video about cylinders and cones. That the cone is always going to be smaller volume than the cylinder, and that this is all based on volume, and that this will not work if your radius and your height are not the same as your cone or your cylinder. And we have also learned about our real-world example where 3 cones can fit into 1 cylinder. Thank you for watching, Miss Irving, and I hope you enjoyed it.
Volume.